Thursday, 6th of June 2019, IGCSE Maths Paper 2HR. Okay, so on this question, we have to write down the inequality shown on the number line. And you must not forget to use the letter that they provide, which is x. So the numbers to the right-hand side of -3 are greater than -3. So one way of writing this is x, which is the number, is greater than -3. They will also accept, if you write it the other way around, -3 is less than x, whichever way you prefer. Next one, we solve this as if it were an equation, but you must not change the inequality to an equals symbol. Do not do that. So, the technique I'm going to use is I'm going to gather all the y's on one side and all the numbers on the other side. And I like to draw some little bubbles here. Okay. And I always tend to have deal with the least y's. Okay. So, I'm going to subtract y from both sides. I'm going to add 13 to both sides. And when I do that, I end up with something like this. 4y minus y is less than or equal to 8 add 13. And then you have 3y is less than or equal to 21. And then divide both sides by 3. Y is less than or equal to 7. You must not write 7 on the answer line. When it comes to inequalities, it has to be, you have to write the entire calculated display on the answer line. The answer is given in this question, so you must show carefully. First of all, by changing the numbers to top heavy, changing the fractions to top heavy. Now, for whatever reason you find this challenging to change fractions to top heavy or improper, press Shift and the fraction button. So then it comes up with 3 boxes and type in 5 2/3, and that's 17 over 3. Okay, you can do that obviously yourself. 3 times 5 add 2. 3 times 5 is 15. 15 add 2 is 17. And with the next one, 4 times 2 add 3 is 11 over 4. The technique for adding and subtracting is to get a common denominator. So 3 and 4 both divide into 12, so use 12 as your common denominator. I like to just draw a little arrow here and write down how I get from 3 to 12, and I times by 4, and this one I times by 3, and then I do the same to the top. So if you times the numerator by 4, we end up with 68, and if you multiply the numerator by 3 here, we end up with 33. When you have the same denominator, you can just subtract or add the numerator accordingly. In this case, we're going to subtract, and we end up with 35 over 12. Now, it looks like you have maybe scored full marks, but no, you haven't. You have to write equals the exam board's answer at the end in order to gain full marks. And it's wise to check if your answer is actually the same as the exam board's answer. So type in 35 over 12. Press equals, press Shift, press the S to D button, and then you can check. Next question. Okay, if you're not familiar with the table mode on the calculator, all Casio calculators have a table mode, whether it's the Class Whiz or whether it's the older model. Just press Menu and find Table. In this case, it's number 9. Enter your equation. So 1 plus 5x. Now the x on most calculators is here, so you have to press alpha x. On this Class Whiz, there is an x button. 5x minus x squared. Press equals. If you do see this screen that says g of x, just press equals again. And then you type in your start, end, and step. The start is where the x value at which the table starts. So -1, press equals. And then 6 to end, and then the table goes up in ones, so we'll leave the step as 1 and just copy down the missing values from the table. So when x is -1, y is -5, what else? When x is 1, y is 5. When x is 4, y is 5. When x is 6, y is negative 5. And we're just going to plot these points now on the graph. Okay, of course use a pencil for this in case you make a mistake. So negative 1 goes to negative 5. 0 to 1. 1 to 5. 2 to 7. 3 to 7. 4 to 5. 5 to 1. And then a 6 to negative 5. Okay, that's good. Plot the points. Now your curve has to go through all of the points. If it doesn't, you may not score full marks. Another thing to notice about this one is this is a parabola, and parabolic curves are curves, so you must not join with a ruler like a dot to dot. At the top of this graph, it's supposed to look like, you know, a curve, a sad face like this. It is not supposed to look like this. So between these two dots at the top, there must be some kind of evidence of a curve. Next, similar shapes. Okay, it tells you at the top the triangles are similar, which means you can work out the scale factor. So find two sides that match, and you look at between the angles. So it has to be between the sides that match are between the same angles. So 16 matches with 40. The scale factor there is 40 over 16, and we can have a look at that and see if it's a nice decimal. So 40 over 16, that's 2.5. Okay, so it tells you the lengths on the triangle on the right hand side are 2.5 times the size of the lengths on the triangle on the left hand side. So you want to work out DE, which corresponds to the left hand side of the triangle. We just need to do 12 times 2.5, and that gives us 30. Next, the area of triangle DEF is 525 centimeters squared. Write it in meters squared. Okay, so you write down the fact that links centimeters to meters. Okay, 100 centimeters in a meter, and what you want is a fact that relates centimeters squared to meters squared. So if you square everything, 100 squared is 100 times 100, which is 10,000. 10,000 centimeters squared. 1 squared is 1 times 1. So there you go. This is the fact that links centimeters squared to meters squared. So as you can see, if you want to convert centimeters squared into meters squared, you have to divide by 10,000. If we divide 525 by 10,000, we end up with the answer 0.0525. If you type this into your calculator, some calculators come up with standard form, a bit like this, 5.25 times 10 to the minus 2. That's also fine. Next question, factorize. I like to use a method called the AM method here, where we draw our two sets of brackets, write an x at the start of both, and we figure out two numbers that add to make negative 5, but multiply to give negative 36. So think of your factors of 36. There are plenty of them. Numbers that multiply to give 36. Okay, but also will add together to give negative 5. And if you do that, you end up with positive 4 and negative 9. Okay, do not try to solve this, because you can't solve this because it's not equal to 0, not an equation. Just write this on the answer line, and that's fine. On this next question, we have a probability table, and probability tables always sum to 1. So we can work out the probability of mint by adding the probability for banana, strawberry and chocolate and subtracting from 1. If we do that, we end up with 0.21 for mint. The question says, work out the probability that the flavour Julius takes is either strawberry or mint, or in probability means to add. So it's 0.32 add 0.21. And when we type that into the calculator, we'll work it out in our head. That is 0.53. Okay. Either you can choose to write this as a decimal, or a fraction, or even a percentage if you want. Okay, so next we have the number of games won to drawn to lost. So we have 1 to drawn to lost is in the ratio 6 to 3 to 2. A team played 55 games. Yep. This 55 games is distributed between won, drawn, and lost. So we can add these ratio parts together, and when we do that, we end up with 11. Okay. So we're going to share 55 by 11, divide 55 by 11, and we end up with 5. 5 is worth 1 part. So if I want to work out each of these, won, drawn, and lost, I will multiply each of them by 5, because we have 6 parts and 3 parts and 2 parts. So we end up with 30 to 15 to 10. Okay. The question says, work out how many more games the team won and lost. So it's the difference between 30 and 10, which is 20. Next question, find the highest common factor. Right, so with this, what you need to do, there is a technique where you can use a Venn diagram for this. You could just also look at the numbers and work it out. So for the highest common factor, you go through each of the different prime factors and look for the highest power of each different prime factor, provided it is common to A and B. So if we take a look at the 3's, 3 is in both. The highest power of 3 that it divides into A and into B, has got to go into both of them, is 3 squared. Out of the 5's, the highest one that's in both of them is 5 cubed. And out of the 7's, we choose either of them, both the same, 7. 11 is not in both, so we can ignore 11. Now, what we need to do is work out the value of this. So 3 squared times 5 cubed times 7. Oops. Times 7, and we end up with 7,875. The LCM is quite a similar explanation, but it doesn't need to be common to both. So we choose the highest power of each number, but it doesn't need to be common, so it doesn't need to be in both of them. So out of the 3's, you choose the highest one that you can see, 3 to the power 4. Same with the 5's, same with the 7, and even same with the 11, because it doesn't need to be in both. So if we type this into the calculator, we end up with 3,898,125. Next one, standard form. Okay, you can just so one way of doing this is to write down the non-zero digits, 8 and 4. The decimal point goes after the first one, and what you need to do is figure out what you multiply 8.4 by to end up with this. So some people like to draw these little arches. The decimal point lies between the 8 and the 4. And it's 1, 2, 3, 4, 5. Okay. To be honest, there's no excuse for getting this question wrong, because you can check it on the calculator. Now, there is a way to set your calculator into standard form mode. If we type in 840,000 and I press equals, it just comes up as 840,000. But if you go to menu, sorry, not menu, shift menu, number format, you want it in scientific mode, which is the same as standard form. Yep. Select a menu from 0 to 9. If you select 9, and what we can do is we can ignore the 0 placeholders. So if press equals now, it comes up in standard form, you see. We just ignore these zeros. We do 8.4 times 10 to the 5. The next one, okay, it's just a case of typing it into the calculator as it is on the page. So 6 times 10 to the power of 7, close brackets, divided by brackets 8 times 10 to the power of negative 2. Okay, and again you can ignore these 0 placeholders, so it's 7.5 times 10 to the power of 8. Next, hey, there's a formula for depreciation. So you take your initial value and we multiply it by the bracket, which is 1 minus x over 100 to the power of the number of years. So the yacht is 150,000 euros. We multiply this by brackets 1 minus 18 over 100 to the power of 3. Okay, type this into the calculator. We end up with 82,705.2, but because it says to the nearest euro, it's 82,705. Okay, next one. So there's so many ways to work out the equation of a line, or ways to work out the gradient at least. I prefer to use a formula. The formula for gradient is this: m equals y2 minus y1 over x2 minus x1. You may have been taught the triangle method. The triangle method is okay as long as you remember that the gradient is negative. There's a lot of students forget, which is why I don't like the triangle method. So just choose 2 points that lie on the line. Okay, one of the points I have chosen is minus 2, 3. Another point I have chosen is minus 1, 1. Label your coordinates x1, y1, x2, y2. Very carefully substitute it in the gradient formula. We have 1 minus 3 over minus 1 minus negative 2. Okay, we type this into the calculator as it is on the page, and we end up with negative 2 there for the gradient. Now the equation of a straight line is in the form y equals mx plus c at GCSE level. So y equals minus 2x plus c. C is where the line intersects with the y-axis, the y-intercept. So as you can see there, it crosses at negative 1. So you can leave your answer like this. Okay. You may have been taught a slightly different formula, an A-level formula, which is like this: y minus y1 equals m brackets x minus x1. So that's okay as well. If you just choose like a point on the line, so like let's say we choose, I don't know, the first one, negative 2, 3. So you've got y minus 3 equals m brackets x minus 2, so x plus 2. Yeah, so it's just, if you choose to write it like that, that's an A-level formula. Normally I'd just expand it and write it in the form y for y equals mx plus c at this level. Next. Okay, there's several ways to answer this question. You can use the sine rule here and treat it as one big triangle, but because this overlaps with the foundation paper, if you split it into 2 right-angled triangles, treat them as 2 right-angled triangles and use basic trigonometry as SOHCAHTOA in each one, that's absolutely fine. The common thing about the 2 triangles is the line BD. It's common to both. So if you work out BD using the triangle on the right-hand side, we can use the length of BD to work out the length of AB later on. So let's try and work out this length, which is common to both. We can use trigonometry. Okay, if I call it x, and then the side opposite to 32 is known as O. The side opposite the right angle is the hypotenuse, so it's O and H, which is SOH from SOHCAHTOA. So if we draw the SOH triangle that goes like this, SOH. Okay, and then draw it again and attempt to fill it in. So we have sine 32 and then x and then 3.1. So cover x, yep, and sine 32 and 3.1 are next to each other. do sine 32 times 3.1. Make sure you're in degrees mode. Okay. Oh, my calculator's still in standard form, so I need to change that number format. Normal. Okay. So, all right. 1.627. Blah blah blah. 1.6. Oh, 1.642. Okay. Now, I may wish to use this number a bit later, so I'm going to store that to A. I'm going to store that to the letter A. So if I press stow for store to the letter A, it's stored in there now. Okay, it won't disappear. Okay, and then go to this other triangle. So if I just replace that, that's 1.6, etc. You must not use the rounded value. You have to use the entire calculator display. And I'm trying to work out the length of AB now. I'll call this Y. We used a different letter to this one. This is also the hypotenuse. The side 1.6, which I also have to use now, this is the adjacent. It's adjacent to 42. So now I need to use the one with A and H in, and that's cos, ka, from SOHCAHTOA. So ka, draw the ka triangle, okay, and attempt to fill it in again. So we have cos 42. A on the side here is 1.642, etc., the entire display, and we have the hypotenuse there, which is Y. Okay, you cover Y, and if you cover Y, it's 1.642, etc., divided by cos 42. Okay, now because I haven't used the calculator for anything else, I can use the ANDS button because ANDS recalls the last display, or I can use A because I've stored it to A. So if you do choose to store it to A and you prefer to use A rather than ANDS, the advantage storing it to A has is that it will always stay there, whereas ANDS, this button at the bottom, only recalls the last display. So alpha A over cos 42. Yep, and that gives me 2.21. Okay, copy down a little bit more because it's the final answer, 0.5, blah blah blah. And the final answer is 2.21. Next. Hey, you have a cumulative frequency curve here. Cumulative frequency is plotted at the upper bound. Okay, so we're going to try and plot these points. So 40, have a look at the scale carefully. Okay, just like to mark in the middle, that's 10. So 5 squares for 10. 10 divided by 5 is 2. Each square is worth 2, so go 40 goes up to 6. You're allowed to be half a square root maximum. 50 goes up to 20. 60, 56. 84, and then 95, and then 100. Okay. You can draw a curve. You can join from 0, you can join from first to last. They do accept a dot to dot as well. That's entirely up to you, whichever one you prefer. Just go for the standard one, join from 0. The curve has to go through all the points. So it's a smooth and freehand curve. Okay, or it can be dot to dot. That's entirely up to you. Use your graph to find an estimate for the median length of time. Okay, the data goes up to 100. Yep, so the median occurs at 50. If I draw it here, M. Now please draw a line across. Okay, this is your working out. Use a ruler and a pencil to do this. So draw a line across and then draw a line down. Okay, I like to show the examiner as well, look, with some arrowheads. Look, I'm going across and down. Yep, and when you do that, you end up with an answer of 59. They're quite strict on this. Okay, they accept either 58 or 59. Okay, 58 to 59. If you end up with an answer 58.5, that's also fine. Next one. Use the graph to find an estimate for the probability that this adult went for a walk for more than 72 minutes. So more than 72 minutes is the bit above 72 minutes. So this time we find 72 minutes at the bottom, draw a line up to the curve, and then go across. Okay. Now remember, each square is worth 2. You must not forget that, but it's the bit above because it says more than 72. So I end up with, that looks like 86 to me. So 86, so that means that's 14. So it says probability, 1 of the 100 adults is chosen. So 14 over 100 is absolutely fine. They will accept 12 or 13 or 14 over 100 or 0.12 to 0.14 inclusive. This next question uses a law of indices, which is x to the power m to the power of n is x to the power of mn. So if we do x to the power, so it's 12 times 3/4. Okay, type that into the calculator, 12 times 3/4, and that's 9. And then y, and then 8 times 3/4 is 6. Next one. 2 of these numbers are powers of 3. That means we should make the 9 a power of 3 as well, so it's all the same and consistent. 9 is 3 squared. So if we change 9 to 3 squared, we will end up with something that looks like this. 3 squared, and then it's to the power of y, so that makes 3 to the power 2y. There is a law of indices that says x to the power m over x to the power n is equal to x to the power of m minus n. So if I apply that law here, it only works when the base number is the same. So this is a x, and this is an x, and same here, this is 3, and this is 3, so I can use this rule now. So it's going to end up as 3 to the power of x minus 2y. And on the left hand side, that's equal to 3 to the power of n. They're asking in this question, find an expression for n in terms of x and y. Well, n is the power here, and the power on this side is x minus 2y. Because they're both powers of 3, they must be equivalent, and that means n is equal to x minus 2y. Okay, next question. So lots going on here. Work out the size of angle DBC. DBC, right, that's this one here. Okay, so lots of angles we can mark on. Okay, how about this one first of all? So we have angle AOD is 98. This one must be half of that, which is 49. Okay, so we can write down a sentence, but it's nice to write it on the diagram as well. So this angle ABD equals 49 degrees. That's angle at the center is twice the angle at the circumference. Okay, that's good. Another one, there's a right angle here, yeah, and that's because AC is a diameter. So let's take a look at AC, which is here. If you take the ends of the diameters, the red line, and lead up to a point on the circumference, so go to B, so from the red line to a point on the circumference, it will make a right angle, and that's called angle in a semicircle. So we have another angle there, that's angle ABC, and that's 90 degrees. Yep. Which means this one is fairly easy to work out, because if that's 90 and this part of it is 49, the other bit must be 41. Yep. We don't need to write a reason for that. Just need to write the answer on the answer line. 41. That's the one we're trying to work out, DBC. Okay, wonderful. Okay, so y is inversely proportional to the square of x. You start off like this. Y equals k over x squared. Inversely is k over. Square of x means x squared. The second stage to this is to work out k. You can use any values in the table to work out k. I'm just going to choose a random one there, so just choose that one. 9 equals k over 2 squared. 2 squared is 4. And 4 times 9 is 36. So k is equal to 36. So the orange bit is first mark, the purple bit is the second mark, and the final mark is for writing the first line, but with your value of k substituted, so 36 over x squared. Yep. And then next, use your answer to part A to find the value of x when y is 144. So write down 144 equals 36 over x squared. Okay. And then all you're going to need to do is rearrange this. Okay. So if I do a little bit of rearranging, I end up with x squared equals 36 over 144. That's x squared. The opposite of squaring is to square root. If you square root this in the calculator, we end up with plus or minus 0.5. It won't come up with plus or minus, but it is plus or minus. And because x is positive, we just take the positive. Okay then, so on this proof question, number 17, we have to prove algebraically, meaning using algebra, that the sum of any two consecutive terms of this sequence is always a square number. Okay, so the table above is very useful. Okay, just got to break this sentence down slightly. So sum means to add, and consecutive means they follow each other. So the sum of the terms of two consecutive terms is always a square number. Now, if we just take a look at the terms of this sequence, so 1 times 2 is 2, 2 divided by 2 is 1, 2 times 3 is 6, 6 divided by 2 is 3, and if you add these two terms together, because they're consecutive, 1 add 3 is 4, 4 is a square number. Right, but this doesn't get any marks, but you can see what's going on. You have to add the two consecutive terms together, and apparently they always end up with a square number. We're going to prove this using algebra. So if you take a look at the fractions, let's have a look at the numerator. We have a number in the numerator, and the one after that we're multiplying it by is one more than the previous number. So if we call, say, the first number n, we're multiplying it by one more than n, n plus 1, and then we're dividing it by 2. And for the next fraction, the first number is the same as the last number from the previous fraction, so that's n plus 1, and we're multiplying it by one more than that number, so 1 more than n plus 1 is n plus 2, and then we're adding them together. Okay, good. When we add two fractions which have the same denominator, you can keep the denominator the same and just add in the numerator. Okay, so I'm going to add these two numerators together, but I'm also going to expand as well. So n squared plus n. And for this one, okay, if you draw all the lines or expand whichever way you feel comfortable, we'll end up with something like this: n squared plus 2n plus n plus 2. So we simplify this, and we end up with 2n squared. We've got n plus 2n plus n, which is 4n plus 2 over 2. Okay, in the numerator, we'll factorize the 2. Right, 2's cancel, common factor. And we're left with n squared plus 2n plus 1. Now, this also factorizes. I like to factorize this using what I call the AM method. Two numbers that add together to give positive 2, but also multiply together to give positive 1. So we set out the brackets like this. There are only two numbers that multiply to give 1, two integers anyway. 1 and 1. They also add together to give 2. Wow, would you look at that? It's n plus 1 times n plus 1, which is the same as n plus 1 squared, which is obviously a square number. Next question, functions. State which value of x must be excluded from any domain of the function f. Right, there is a fact in maths that you cannot divide by 0. That's illegal in mathematics. You cannot divide by 0. So, you need to think, what value of x in the denominator would produce a denominator of 0. So there's one way to figure that out. You set the denominator equal to 0 and rearrange to work out the value of x. So add 3 to both sides, then divide by 4. So 3 over 4. So the answer there is 3/4. 3/4 is not allowed. Now, I don't know if this is going to work, but we'll try. We'll try this. X over 4x minus 3. Okay. So we can see that it looks a bit like a 1 over x graph. And the graph goes crazy about here somewhere. We just worked out that value is 0.75 or 3/4. The graph doesn't exist there. You see, it exists everywhere but there on the x-axis. So if you do have a graphics calculator, you can check and verify your solution is correct. Okay, next. So find fg of x. So you always do the bit on the right hand side. You have a composite function, and this gets substituted into the first letter. So g of x goes into f of x. So g of x is equal to x minus 5. So we can rewrite this as f of x minus 5. And this is going to go into the f function. So what that means is, in the f function, where you see x, replace it with x minus 5. X minus 5 is your new x. Okay, so draw a fraction line. Remember, where you see x, write x minus 5. And then we have 4 times x, your new x, which is x minus 5. And then minus 3. So if we tidy this up a little bit, on the top we have x minus 5. In the denominator here, if we expand, we get 4x minus 20. So you get 4x minus 20 minus 3 is minus 23. And this is the final answer to the question. Express the inverse function. So a few stages to this. What we'll do to begin with is replace the f of x with y. So we'll rewrite this as y equals x over 4x minus 3. Some teachers will now say to rearrange this to make x the subject and then interchange your x and y. What I prefer to do is interchange the x and y to begin with and then rearrange it to make y the subject. So I'm going to swap x with y. So it's going to, every time I see an x, I've got to write a y, and every time I see a y, I write an x, like this. That's stage 2. Stage 3, try to make it y equals, so just rearranging. If we multiply both sides by 4y minus 3, expand the brackets, okay? Nobody writes x for y. You just don't do that in maths. If you have a combination of letters and numbers times together, it's always the number that goes first. So 4xy minus 3x equals y, yes? And what we want to do now is rearrange this to make y the subject. So we've got 4xy minus y equals 3x. Take y out as a common factor. So we have y brackets 4x minus 1 equals 3x. Then divide both sides by 4x minus 1. So you have 3x over 4x minus 1. And that's equal to y. Which you can now write on the answer line. That's the final answer. Right, this is quite hard to do using the software, but when it says estimate the gradient, I mean, this is a pretty naff way of doing things, because if you have the equation of the curve, of course we can use differentiation, but when we're estimating, we're just going to draw a tangent to the curve. and you must draw the tangent to get the mark. So what you need to do with this question is take your ruler and find x equals minus 0.5. So if we find that, x equals minus 0.5, place a little dot on the curve, and what you need to do is line your ruler up so that it's a tangent to the curve at that particular point. So it's got to just skim the curve. Let's just try this. So hard to do on here. Okay. Okay. Something a bit like this. Yeah. So it's obviously a lot easier for you to do it with the ruler against the question. So what you need to do, just line your ruler up like this and draw a tangent so it touches the curve at that one point only. So let's have a go on here. I'll try. Yep. And that's the definition of a tangent. It touches at that one point of contact. What you then need to do is find 2 points that lie on the line that you can easily read off. So let's have a go. That one seems alright to me. Okay. There is some leeway in this question. I'm going to write down my coordinates now. So I have minus 1.57, and then my other coordinate is 0, what's that, 17. Okay, and I'm now going to use the gradient formula to work out an estimate for the gradient. So I'm going to write underneath the coordinates x1, y1, x2, y2, and substitute into the formula. The formula goes like this: for gradient, y2 minus y1 over x2 minus x1. So we have 17 minus 7 over 0 minus 1.5. Okay. Let's type this into the calc. I get 6.6 recurring. It's okay to write that down. You are allowed to have any answer between 5 and 7, and that's acceptable. So it's quite a range there of values to accept, but 5 to 7, so I'm just at the upper end. But then again, I'm doing it on software, so it's not too easy. Okay, next question. So we have sectors. Okay. And it gives us the area of a sector, and we need to work out the perimeter of the shaded segment. Okay, so we'll start off with the formula for the area of a sector. Well, the formula for the area of a circle is pi r squared, and the formula for the area of a sector is pi r squared times theta, the angle, over 360. So angle over 360. Yep, this is the area of a sector formula. So if I start off with that, then I have pi times r squared times 80 over 360 is equal to 25 over 2 pi. I can do a bit of cancelling here. There's a pi on both sides. Cancel. I just need to rearrange this now to work out what r squared is. So we have a multiply by 80 over 360 on the left hand side. What I can do is I can type in 25 over 2 divided by 80 over 360, and that's going to work out what r squared is. R squared is equal to 225 over 4, and that means r is the square root of that, the positive square root of that, of course. That's 15 over 2, it's 7.5. So I've worked out what r is so far. Now, to work out the perimeter of the shaded segment, that's two parts. We have the line AB, the straight line AB, and then there's the curved bit at the top, APB. So all I know now is the radius of the circle is 7.5. I can work out the straight line AB because it's the missing side of a non-right angle triangle, and I can use the sine rule or cosine rule here, depending. I just need to go through the checklist in my head. Do you know a side and its opposite angle? And the answer is no. I do not know a side and its opposite angle. When the answer is no, you have to use the cosine rule. So we'll use the cosine rule. Okay. Cosine rule from the formula sheet is a squared equals b squared plus c squared minus 2bc cos a, where b and c are the two sides either side of the angle, or as I like to say, the two sides that sandwich the angle. So, two sides that sandwich the angle are both the radii. We have x squared, according to my diagrams, the one I'm working out. X squared equals 7.5 squared plus 7.5 squared minus 2 times 7.5 times 7.5 times cos 80. Yes? And that's x squared. Now, the way I do this, I do not evaluate each of these terms. I shove all of this into the calculator in one long line of working and then square root it. Okay? And when you square root it, you end up with something that looks like this. 9.6418, etc. Okay? So that's great. Now I've worked out this line, the red line. I also need to work out APB. APB is part of the circumference of the circle. And I can show you this, if this works. Okay, so it's a bit like this. You get the idea. This sector is part of a circle. Yeah, it's like a slice of the circle. So you can see that APB is part of the edge of the circle, or the circumference. So we need to use the circumference formula. Circumference formula is pi times d, or 2 pi r, whichever you prefer, 2 pi r or pi d. If I use 2 pi r, so I have 2 times pi times r, which is 7.5. This works out the circumference of the circle. Of course, I don't have the entire circumference here. I only have 80 degrees out of 360 degrees. So, what I need to do is work that out. Yes. And when you type that into the calculator, you end up with around about 10.471 ... So we've got this bit, which is the curved bit at the top, 10.471. We have the straight line, which is 9.6418. Add the two together, and round to three significant figures. Final answer, 20.1. Okay, bounds. So, when you see correct 2, you can get a mark instantly by writing down your upper and lower bound. So, let's just take a look at this. We have, let's think about columns, right? We have hundreds, tens, units. After that, we have tenths, have hundredths, and so on. So, the first number, A, 3.46, has been rounded to 3 significant figures, and the 6 is in the hundredths column. The hundredths column is the same as saying 0.01. If you divide 0.01 by 2, you get 0.005. This is what you need to add and subtract to 3.46 to work out the lower and upper bound. So you take the value of the column, which in this case is 0.01, divide it by 2, and then add and subtract it to 3.46. And when you do that, you end up with 3.455 for the lower one, 3.465 for the higher one. Okay. For the next number, 6.3, the 0.3 is in the tenths column. Tenth is 0.1. Divide 0.1 by 2 to give 0.05. Then add and subtract it to 3.6 to end up with 6.25, 6.35. Okay, we want the upper bound for the value of x. So what we want here is we want the greatest value of in the numerator, and the lowest value in the denominator. That's how you get the greatest value of a fraction, of the biggest number in the numerator, highest number in the numerator, lowest number in the denominator. So here we go then. We're going to use 6 times 3.465 in the numerator. In the denominator, I've got a choice here because I need to do b minus a. If I draw a little number line and show you what's going on, at the lower end we have a choice of a is 3.455 and 3.465, and b can be as low as 6.25 and 6.35, and we're subtracting, you see. When you subtract two numbers, you're working out the gap between the two numbers. And we're saying that we want the gap of b minus a to be as small as possible, the lower bound. So we're going to use the lower one of b, remember this is b, and the higher one from a, because then the gap is going to be as small as possible. So 6.25 minus 3.465. And when you type this into the calculator, we end up with a final answer to three significant figures of 7.46. So this question is about similar shapes to do with length, area and volume. Length is associated with scale factor, area scale factor squared and volume scale factor cubed. We are given information about the surface area of bottle A and the surface area of bottle B. So I'm going to work out the scale factor squared between A and B. And I can do that by dividing 540 by 240. This gives me the scale factor squared. So 540 over 240 is equal to 9 over 4, which is 2.25. Okay, so I can write here that this is equal to 9 over 4, or 2.25. And that's all I can do for the time being. They tell me the volume of bottle B. So as soon as I see the word volume, I think, hang on, I need SF cubed. Now it's hard to get from SF squared to SF cubed. The easiest way is to go from SF squared to SF, and then from SF to SF cubed. So to get from squared to scale factor, I square root it. Square root 9 over 4, and that gives me 3 over 2, or 1.5. So SF cubed is what I need. So now you cube this answer. If you cube 3 over 2, you end up with 8. Beg your pardon, you end up with 27 over 8. So that is the same as 3.375. So to get from bottle A to bottle B for volume, we multiply by 27 over 8. To get from bottle B to bottle A for volume, you divide by 27 over 8. And we are given the volume of bottle B, which is 2025. So we divide that by 27 over 8. So 2025 divided by 27 over 8. That's 600, which is the answer to the question. Next question. Number 22, completing the square, where we have a negative 2x squared. So this is quite an awkward question, unless you take out a factor of negative 2. That makes the question a lot easier to deal with. Because really, you want to complete the square, and it's fine to do when you have an x squared as the first term. So how do you get an x squared as the first term? Well, factorize a negative 2. So if we do that, we end up with x squared. And the way to figure out what goes in this bracket is you divide each of these by negative 2. So I'm starting off with the x squared because we normally have that as the first one in the bracket. Then if I divide 12x by negative 2, you get negative 6x. And if you divide 5 by negative 2, you get negative 2.5. Inside the bracket, I can now complete the square. So I'm going to introduce some square brackets here because I'm going to have curly brackets within the square brackets. When you complete the square, you have x, and then half of the number attached to the x term, so half of -6 is -3, in brackets squared. Then you subtract the number in the bracket squared. So 3 squared is 9, so you subtract 9, and then you copy this number at the end, so you copy the -2.5. What we can do now is simplify what's in the square bracket. So we end up with -11.5 here. And finally, we can multiply out the square bracket like this. So if I times -2 by -11.5, I end up with +23. And if I times the bracket by -2, I end up with -2 and then the bracket. This is the answer to the question, and it's in the correct format as well. Right, the next question. This is a pyramid, and we're asked to work out the size of the angle between AC, which I'll go over, let's have a look, in red, and the base BCDE, which I'll highlight. Okay, so we're trying to work out the size of the angle made there. Now we need another line on this diagram, because when we're working out the size of an angle between say like AC and the base, we need to draw a line which is on the diagonal of the base. So we need to work out this angle here. So if we draw out the triangle separately, let's do that. So label it. So this is A, C, no, I beg your pardon, sorry. This is A, O, and C. Now, it's hard to see from this direction, but the black line and the dotted line are perpendicular to each other, because the black line sits on the horizontal plane and the dotted line is vertical, and the angle between a vertical and a horizontal is 90 degrees. So it's 90 degrees here. I'm trying to work out the size of angle ACO. So I'm looking at this right angled triangle here. If I just draw another line to see, so here we go, we have, yeah, they match now. So we've got AO, AC and OC, and this is the angle I'm trying to work out. So let's have a look at the information then. What do we know? Well, the total surface area of the pyramid is 360. So let's consider what the net of a pyramid looks like. Let's see if I can find one. That'll do. Okay, so we have something that looks like this. Now we know that the base is a square, so that's 10 by 10. We also know that the other 4 triangles are the same size. So the total surface area is 360. The square on the bottom has an area of 100 centimeters squared. And that means we can work out what each of the triangles is equal to as well. So 360, take away 100, divide by 4. And that will work out the area of one of the triangles. So the area of one of the triangles is going to be 360, that's 260 over 4, that's 65. 65 centimeters squared. So let's take a look at one of these triangles then. We have a triangle that looks like this. The area of it is 65, the base of it is 10. How do you work out the height of this triangle? That's the height here, not the slanted one, the height. So the formula for the area of a triangle is base times height divided by 2. So 10 times h divided by 2 is equal to 65. A little bit of rearrangement. 10 times h equals 130, and 130 divided by 10 is 13. So the height of this triangle is 13. Let's cross that out and write 13 here. If I consider this now as a right angle triangle, this length is 5 and this length here is 13, I can work out the slanted length by using Pythagoras' theorem. So 5 squared plus 13 squared is equal to x squared, and that means x is equal to the square root of that. So the square root of 5 squared plus 13 squared gives me root 194. Okay, so I have worked out one side that I need. If I go back to the question, I've worked out AC, which is root 194. I can work out OC as well pretty easily, and I'll show you how to do that. OC, you've got to imagine that you're looking down on the shape and there's a bird's eye view. Now, the square is 10 by 10. OC is this line here. So if you consider this triangle, which is 5 by 5, it's easy to work out the length of OC by again using Pythagoras' theorem. So it's 5 squared add 5 squared is equal to x squared. So if I do square root of 5 squared plus 5 squared, that's equal to 5 root 2. Okay, and that has been square rooted as well. So x is equal to 5 root 2. So go back to the diagram. This length here is 5 square root 2. So 5 square root 2. Now, when you're working out an angle in a right angle triangle, you only need 2 sides, and then you can work out the angle. We'll do that using basic trigonometry. The side OC is adjacent to the angle. It's the one between the right angle and the marked angle. The side opposite to the right angle is H, because it's the hypotenuse, and then we can use cosine, C-A-H, CA, to work it out. So we can do that. We draw the CA triangle. It goes like this. I draw it again a little bit bigger and start to fill it in. So we have cos x, cos of the angle, is equal to the adjacent, which is 5 root 2, over the hypotenuse, which is root 194. All exact, very beautiful. Now what I'm going to do is write down the first line of working here, which is cos of the angle is equal to adjacent over hypotenuse, and then inverse cos this to work out the angle. So it's the inverse cos of the line above. So let's have a go then. Shift cos fraction 5 root 2 over root 194, close brackets, and that's 59.49. Okay, and then the question says give your answer to 3 significant figures, so 59.5 is the final answer. Next question, which is the last one on the paper, I think, is a probability question. These are becoming slightly more frequent, so it's definitely a good idea to revise this. So we have a bag that contains red marbles and yellow marbles, and a marble is taken out and not replaced. So let's take a look at this and explore the tree diagram in a bit of detail. So we have red and yellow, and then following on from that, when we take the second marble, there's another red and another yellow option. Okay, so the tree diagram is going to look like this: red, yellow, red, yellow, red, yellow. The probability of red. Now we have to think about this. Okay, there are 4 red and the rest are yellow. So shall we call the yellow ones Y? If there are 4 red and Y yellow, then in the bag there must be a total of 4 plus Y. So the probability of red is 4 out of the total in the bag, which is 4 plus y. The probability of yellow is y, because there's y yellow ones, out of the total in the bag, which is 4 plus y. Let's follow the red branch. If you take a red one out of the bag and do not replace it, then there must be 3 red ones the next time you take one out of the bag. But there's also going to be one less in the bag. So there was 4 plus y to begin with, and then you take away 1 from that. So 4 plus y, take away 1, will give you 3 plus y. And that means all of these branches are out of 3 plus y, because at this second tier on the tree diagram, we have only taken 1 out of the bag. So, go back to the beginning. This time you take a red one. How many yellow ones are still remaining? Well, the same as before, because you've taken a red one out of the bag. So there's still y yellow ones. Go back to the start. This time take a yellow one. How many yellow ones are there next time? There'll be 1 less, so y take away 1. Go back to the beginning. This time take a yellow one. How many red ones are there? Well, still the same number as before, because you've taken a yellow one. Now, I've gone a bit over the top here by drawing the entire tree diagram. You don't need to draw the entire tree diagram, but I thought I would show you just so you can see how to construct it. It says the probability that they both take a yellow is 0.7. That's this branch. Now, when you move along the branches of a tree diagram, we times the fractions together. So we have something like this: y over 4 plus y multiplied by y minus 1 over 3 plus y is equal to 0.7, which I'm going to write as 7 over 10. So when we multiply fractions, we multiply along the top and along the bottom. Okay, so on the top, y times y is y squared, y times minus 1 is minus y. On the bottom, we have double brackets here, and we expand the double brackets and simplify. So 4 times 3 is 12, 4 times y is 4y, y times 3 is 3y, and y times y is y squared. When you simplify all of that and write it in the correct order, you end up with y squared plus 7y plus 12. Okay, and that equals 7 over 10. So what I'm going to do now is use the method where you have, if you have a over b equals c over d, then it's true to say that a times d equals b times c. So I'm going to do some diagonal multiplying here. Okay, and multiply the top here by 10 and multiply the top here by 7. Let's do that. You get 10y squared minus 10y is equal to 7y squared plus 49y plus 84. And when you rearrange this all onto one side, okay, if we to make it equal 0, we do that, we end up with 3y squared minus 59y minus 84. Okay, so we have a quadratic here to solve. We can solve that using the quadratic formula, but just make sure you write y equals and not x equals. So a is equal to 3, b is equal to negative 59, and c is equal to negative 84. Okay, and we'll substitute into the formula. So it's minus b, so it's minus minus 59 plus minus square root b squared, and we write that in brackets, squared on the outside of the brackets, minus 4 times 3 times negative 84, big fraction line, very long fraction line, over 2 times a. We type this into the calc. If you have this Class Whiz or even the CG50, you can go straight to Mode A or Menu A, Polynomial Degree 2, and enter your A, B and C. So 3, negative 59 for B, negative 84 for C. So you get 21 and negative 4/3. Now remember, what we're working at here is the number of yellow counters. You can't have minus 1.3 recurring yellow counters. So there has to be 21 yellow counters to begin with. And the question actually asks, work out how many marbles were originally in the box. Well, if there's 21 yellow and 4 red, that means there were 25 in the bag originally. Thank you very much.